Better make a video, right? Okay, so this is an experience that you may have. You may leave lecture on a particular day thinking, wow, that totally made sense. I get it 90%. I was with Mark almost the whole time, and I really understood it. But then an hour goes by, 2 hours, you have another class, you hang out with your friends, then you go do something else, then you're studying for another class, and now so 6 hours, 8 hours have gone by, and this is going to start fading. Okay, it's not. You're not going to have the retention and the understanding that you did when you walked out. That's what the videos are for. You go back and watch it that night, watch it the next day, watch it before the exam, and you can kind of relive that experience where you really understood it, and then now we start to retain it. Right now we start to really learn it and becomes part of our understanding. Okay, so just one pass at new material is not going to be enough in this class. Okay, that's why the videos are there. Don't forget about class videos. Okay, what else? Let's talk about the homework. So let's see how the poll's going here. Everyone made your... So you get a little bit of participation points for these polls, so even if you don't have a preference, just go ahead and answer. No, let's see. Here we go. Maybe this one. Okay, water droplet. Awesome. That's the one I wanted to do. So let's look at the water droplet problem. Okay. So in these homework problems and in the text, there are videos, okay? These little animations. So it's not, these animations are not designed for you to sit back, watch them once, and go on. The animations are there for you to dig in and understand what that animation is about. You have to relate it to, so if this were an animation in the text, not a homework problem, you have to relate it to the conversation or the discussion of the text around it. That means watching it, thinking about it, pausing it, watching it more than once, but you have to engage. You have to be active with these animations and videos. You can't just passively watch them once and then read on. You have to relate them to the discussion and really ask yourself, what is this animation trying to show me? What's the main point? What's the main idea? Okay? And if you can't answer that question, then watch it again, keep thinking about it, and if you still can't answer it, then ask. Ask someone in office hours or email a TA. Okay, so here's this animation of our water droplet. So when the water splashes, it creates ripples, right? And so the ripples expand, and we're saying that when it gets to 2 meters, that's when the ripple kind of disappears. So let's watch it again. Maybe. So we see this. You see this ripple. So there's one moving out. Okay. So the first one is to define constants and variables. And if there's a constant whose value we don't know, we can assign a parameter. That was one thing I didn't really emphasize in last class. So parameters are for constant values. And they're especially helpful when it's a value we don't know. That's why we're going to assign a letter to it. We need to have some symbol to represent that constant value that we don't know. Okay? You can use one for a value that you do know, that's fine, but really they're the most useful in a case where, okay, we know it's constant, but we don't know its value, so we're going to assign the letter C to it, for example. Okay, so what is constant in this situation? Possible constants. Can you think of any constants in this situation? Yeah. Okay, so she said the maximum radius of the ripple. Is that a constant? Yeah, so at 2 meters, so that's a good one. So when the radius hits hits 2 meters, that's when it dissipates, and so the radius, we'll say, and what do you want to call that? Capital R. Remember that parameters and variables are letters. If I just wrote the max radius, that's a constant quantity, but it's not a parameter until I give it a letter. That capital R is the parameter. Okay? All right. How about one more possible constant? Yes, sir?
The center of the ripple.
The center. So that's a location. That's true. The center doesn't change, but that's a location and not a quantity. Okay? So a quantity is something that takes on a value. Yeah, yes, sir. Okay. Pi is a constant associated with circles. Sure. So pi is a parameter. Okay. So one more. Yeah.
The max area or the circumference.
Which one do you want? Those are two different things.
Area.
So what do you want to call that?
Just capital A.
Capital A, max area. And we probably should put some units on these. The radius is going to be in meters. Pi is unitless. Max area would be meters squared. Okay, so there's some parameters. All right, what about variables? So, see, here's one way I could use this. I could pause it. Okay, so here I've paused it, and we're looking at, say, this ripple right here. Okay, so there's that ripple, and then I could start it up again and pause it. And where's that ripple gone now? So that ripple is now here. And we could ask, what changed? Right? What kind of things changed? Yes. Circumference. What do you want to call that? C is the circumference of a ripple. Beautiful, okay? And that would be in meters. Another variable. Yes, sir? Radius of the ripple. So you see that, so R is the radius of a ripple. Do you see the difference between big R and small r? What's the main difference? What's the key difference between capital R and little r? Little r is a changing quantity. Little r stands for a changing quantity. Why? We just saw a change, right? I paused it first time, and then I let some time go by, and I pause it again. The radius changed, right? It was this was r before. This was r before, and then later, then r became this. R changes. Okay, and then what? So similarly, the area. So maybe, I guess we could use little a. Little a is the area inside a ripple. Changing, right? If I just say the area inside a ripple, that's changing because as time goes by, that area is changing. But if I say A is the max area within a ripple, well, there's only one biggest area that it could have. What's another important changing variable in this situation? Aiden? Okay, good. Right. So say it again. You want to say T is?
T is time elapsed since initial.
Time elapsed since the drop hit the water. Sure. And we want that in seconds. So you can't see that, but obviously, in order to have all these changing quantities, time has to be changing in the background, right? Time has to be changing in order for something else to change, right? So that's always a key changing variable in these dynamic situations, is time elapsed. Okay, so I think that's good examples. Questions on constant versus changing quantities and parameters and variables, A and B. Yes?
How would you write the intervals for the variables?
Oh, thank you. Okay, so for instance, little a. So what's the domain of little a? So we're asking for the smallest value all the way up to the largest value. So what's the smallest value for the area of the ripple? Yeah, so just the moment that that ripple starts, it has an area of 0. And what's the maximum area that it could have? Well, we called that our parameter. Max is a, capital A. Or we could actually find that. What is that? Pi r squared, and r is 2. So pi times 2 squared? 4 pi, right? So what does this? This signifies all values starting at 0 up to 4 pi and everything in between, right? So those are all the possible values of this changing area A, 0 to 4 pi. Does that answer it?
Yeah, but like for the other area,
So what other one?
like the R.
So circumference would start at 0 and go up to what? Circumference is 2 pi r. So that would also go from 0 to 4 pi for this particular case.
Can you do the one for time?
Time. So we would need the time corresponding to a radius of 2 meters. So we would have to call that something. So I mean, obviously, so this video, I think at the end of the video, I don't think it's probably reached 2 meters in 8 seconds. Okay, so there's some time greater than 8 seconds where the radius hits 2. So we need to call that something. So that's a perfect chance for a parameter, maybe capital T. So we could say capital T is the time it takes for the radius to reach 2 meters. And that would be a parameter. And then we could say the time varies from 0 to capital T. Does that help? So our domain for time could be, say, 0 to capital T, where we define capital T as the time it takes, the amount of time it takes for the radius to reach 2. Yes, sir? What's that?
Like, there's a rate of change that it's expanding,
Okay.
but because we don't know the constantly how long
Yeah, so as we get down to the other questions here, so like, are you talking about like the speed of the ripple? Yeah, so so let's take a look at that. So is the speed of the ripple constant or changing? The speed of the ripple. So here it goes. Does the speed of the ripple, is it constant or changing? Well, for purposes of this problem, I think it's helpful just to assume that it's constant, okay? That speed of that ripple is, as it expands, it's like how the radius expands, is a constant quantity, okay? And so you can't really, from this animation, you can't really tell. So it's okay to assume, to say, I'm going to assume that speed of that radius is constant. And that will make your life easier, okay? So, and I think I think looking at the video, it's a reasonable assumption. If you just kind of watch one, it's reasonable to say that those ripples are expanding out at a constant rate. Okay? All right, so then going on here, especially the relation between the outermost ripple's radius and the closed area symbolically. Okay? So the outermost ripple's radius and enclosed area. So we define those. Those are our R and A. Those are those changing quantities. So what's the relationship between R and A for part C? A equals pi r squared. That area is going to be the area of the circle that has a radius of r. And so what happens? Those quantities change together. R increases from 0 to capital R, and as that happens, our area is increasing from 0 to 4 pi. Yeah, so as the radius increases from 0 to 2, A increases from 0 to 4 pi, and so what? These quantities are changing together. Changing together. This is what we call covariation. And it's not be wrong to say that calculus is the study of covariation. That would be a perfectly legitimate statement. Calculus is the study of covariation. Okay? Now, what about the outermost ripple's area and the number of seconds? Well, that goes back to what we were talking about with the speed of the ripple. So if we wanted to come up here, we could have another parameter, say, called S. Is the speed of the ripple, or speed of the ripple expanding. And what would that unit be? Speed. Be meters per second. And for the sake of argument, we can say, well, those ripples are expanding at a constant rate, so I'm calling that a parameter. S is a parameter because it's a constant rate. Okay? So if that's the speed of the ripple, we need to relate A and T. We really need that middleman of R. Okay? We really need that middleman of radius. So how could we write radius in terms of time? If the speed is S meters per second, then for any number of seconds, how many meters is the radius? S times T, right? S meters per second times the number of seconds is going to give us the current value of the radius. Again, variables R and T, parameter S. Okay? And so therefore, what would A be in terms of T? We've got R in terms of T, and we've got A in terms of R, so we can say pi times ST squared. And now we've just related A and T, which is what they asked for in D. Express the relationship between the outermost ripple's area and the number of seconds. So what are our constants? Our constants are the pi and the S, and our changing quantities are the time elapsed and the corresponding area at that time. Okay. Are we good on this question? Does that clear some things up? So this was answer to C, and this was D. So really, to get D, to bridge that gap from area to time to area, we really need that middleman of radius, and we can write that radius as a function of time, or dependent on time, if we have the speed of the ripple. Okay, so we did that. Okay, so again, just to reiterate, so these animations are critically important in the text. So don't just watch them once and read on. We want to pause them, watch them more than once, really engage your mind and thinking, what is this trying to show me? What idea is it trying to express? Okay? Watch them multiple times and really dig in mentally, okay, when you're reading. Okay, so if you have, many of you are realizing that we really haven't done any calculus yet, and there are a lot of these principles, maybe things you've seen in the past. What we've done is for this first part of the course, we've chosen the very most important ideas that when we get into the heavy-duty calculus, and it's getting difficult. All these things that we're doing now are going to be the ideas that are heavily involved in that when we get to the calculus. So you can't think of this course as compartmentalized. You can't think of it as, okay, I'm going to learn a bunch of this stuff, and then I'm going to learn some of this, and then some more of this, and once I've got that down, I can forget. Everything that you learn, you have to retain, because we're going to see it later. Okay, you got it. Everything that we learn is going to be a part of the bigger ideas that come later. So you have to have the mindset of, when I'm working on something, I'm going to retain that because I'm going to see it again, interconnected with other things. Okay? And like I said, in this first 2 or 3 weeks, we've chosen the very most important things that we will be seeing again, that will all be coming together when we get into the calculus. Okay? All right. So if you have your laptop, let's open up a window for GC. Points. So let's open up GC, Open up a blank window. And let's start talking about how some basics with GC here. So these you have command lines in GC, and in those command lines you can do computations. I think we've seen that. But then you can also, you can mathematically give it a set of points, some kind of relationship that gives a set of points. And then what graphing calculator does is it plots those points. Okay? It does not have a memory bank of curves and lines. It takes the relationship that you give it, and it finds all the coordinated pairs of, say, x and y, and it plots all those points. So the first thing we need to know is how does it graph just one point? Let's just graph just one point. So to do that, you're going to hit Control 2, and you're going to get this vertical vertical bracket. So Control 2 is how you would graph a single point. So let's make x 6 and make y 3. And if you hit Graph, it will plot the point that you told it to plot. So we gave it the point 6, 3, and so then it displays the point 6, 3. X equals 6, y equals 3 is that pink point right there. To get a new command line, are we good? Just use your cursor and cover it just like a word processor. Just take your cursor and go there. And just either put it in delete or cover it. You got it? All right, so a new command line on Macintosh or an Apple, you can do Command Enter. And on PC is Control Enter. It gives you a new command line. So let's do another point. So everyone do another point. Let's do, say, 3 and 1.5. So now we're showing 2 points. Good so far. So like a word processor, you can go into any command line and you can edit it, and then it will just update. So we can go back to this first command line and say, instead of 6, let's put 4. Instead of 3, let's put 2. And now that point that used to be 6, 3 is now displaying 0.42. Okay, so there is a line, and that line is the line that goes through those 2 points would be the set of points that have a certain relationship between x and y. So when I say line, you may think, oh, mx plus b, what intercept and what slope do I need? Don't think about that. Just think about the line through all the points that would extend in a line through those 2 points. What is the relationship between x and y? Think to yourself. Don't say it out loud. Think to yourself. What is the relationship between x and y that would be all the points that would be the line through those 2 points? Okay, so we'll start a new command line. So if I give it that relationship of x and y, then it will plot all the points. Okay? So we've got the point 4, 2 and the point 3, 1.5. What is the relationship between x and y? So if you think you know it, just type it in. What is the relationship between x and y that I'm showing when x is 4, y is 2, when x is 3, y is 1.5? Just type in that relationship and see if you should get the line. So let's see. Where's Caitlin Weber? Do you know what that relationship is between x and y? So how does y relate to x here? When x is 4, y is 2. And when x is 3, y is 1.5. So what is y equal to? Okay, so what would y equal? Y equals, so I've already started y equals. Right. So what we're saying is the relationship is that y is always half of x, right? So now if I put y at half of x, it's going to give me all the points that satisfy that relationship. Doesn't make sense. It does not have a graph of y equals 1/2 x in its memory banks. It just said, oh, you want all points that fit this relationship such that y is half the value of x. Here they are. So when you look at that blue line, you're not looking at a stick. You're looking at an infinite number of points. It just would take too long to draw it that way. You see? It would take too long to draw it that way, so it's a lot faster just to go like this. But then you, as the user, have to know what you're looking at. You're looking at a set of points, not a stick. Okay? All right, so then go down, make a new command line, and just type lowercase n. Just type lowercase n. When you do that, down at the bottom of your screen, you'll see something pop up which is called a slider. So if I grab on that button and move it, what happens is I'm changing the value of n. And so whatever my current value of n is, that's going to show up in that command line, because in that command line it's just n, so it's going to tell me what n is. So right now I've got n at 6.4. I can grab that again. Now n is 8.6. What is this like? What is n? Yeah. N is a parameter. Agree? Really?
No,
It's a variable. It's a variable. It has a changing value, right? So we can manually change it. We can manually change it. I suppose we could, in a certain context, we could use it as a parameter, so I could come along and set it at 4.5 and then do a bunch of other stuff with n set at 4.5, and then it would be a parameter. But the spirit of n here is that it's a variable. So it's a variable that we control the value of, right? We control the value of. So what I want to do is I want to highlight a point on this line using n, so that when I change n, it changes the point on the line that I'm highlighting. So I want n to be the x-coordinate of that point, and then I want to be able to change n and have that point row or change on that line, highlighting different points on that line. Okay? So I want you to do that. So I want you to create a point whose x value is whatever we choose for n, and whose y value then will keep it highlighting a point on this line. Can you do it? Can you do it? So we're going to start a new command line. So I want to create a movable point that highlights points on that line, y equals 1/2 x. Try it. Anyone got it yet? One's got it. Two. Where's Anna Vaughn? Where's Anna? Did you make any progress on this? Yeah, this task here, did we able to create the point, the movable point? Okay, so what is it? First and foremost, it's a point. So Anna, how do I graph a point? Control 2. So if we want a point, then we're going to use Control 2. Now it's just a question of what are we going to set for x and what are we going to set for y, so that we get a movable point highlighting a point on this line y equals 1/2 x. Yeah, you want to volunteer? Go ahead. Yeah, sure. Okay, so she wants x to be n. That's what we said. We want to be able to control the x value. So if it stays on that line, then y should be 1/2 n, right? 1/2 of whatever we have for x. And so some of these colors are kind of faint. The red, the blue, and the purple are the nice bold ones. So I'm gonna make that point say, and there's black too, so I'll make it black. The yellow and the green and the turquoise, sometimes they don't show up very well. So look now, if I change The value of n is doing exactly what I'm telling it to do. It's plotting this point whose x value is n and whose y value is half as much as n, and that's going to be a point on this line of the relationship y equals 1/2 x. Okay, questions so far about GC? Okay, so I want you to go to, yes, please.
Will we be able to use GC on the exam?
No, but they're written that way. So the exams are written knowing that you don't have GC. Okay, that would be ideal for us if we could write exams where you could, but it's just there's too much. It's too hard to monitor, right? So there's too many other things on your computers that we don't want you to see for an exam. So yes, the exams are written knowing that you do not have GC. Okay. All right. So go to Blackboard and go to Readings and Homework, and you'll see the first post in there is a GC file. I want you to download it. So I'm going to show you that. So if you go to Readings and Homework, the first post right there, GC file for class, coordinate point activity. Download and open that file. Download and open that file. That's the coordinate point activity student. And when you open it, you should see this thing, the one on the right. So this file on the right is the one, when you open it, you should see it. Anyone got it yet? Does it look just like this? Okay, great. So the rest of you, go ahead and download that and open it. And then I have my version, which is going to be what you're going to recreate. Okay. So the first thing you want to do, if you see, it says plot the fixed points. So I've given you 3 empty command lines. If you click right there, you'll see there is already a command line there. It's just empty. And so on these 3 command lines, I want you to plot the 3 points that you see on mine. Okay? And they are in nice integer places. Okay? They're all whole values. All the coordinates are whole values. So you got 3 points, and I gave you 3 lines to plot those 3 points. Do that first. Grab a TA if you're having difficulty. Raise your hand and get help if you need help. Where's Julie? There she is. Okay, so we have success getting those 3 points. So the next thing I want you to do is, if you look down the next part, it says, display the portion of the curve shown. Okay, so the curve, this is not a line anymore, it's a curve that is a relationship that all 3 of these points have. Okay? So now I want you to plot all the points that have that same relationship that those first 3 points did. It's not a line anymore. Okay? It's not a line. So you got to look at how x and y compare for each of those 3 points, and actually, what's the relationship between y and x? What's the relationship between y and x? And by giving GC that relationship of y and x, it will plot all the points. See if you can do it. That's what you're going to do in this line right here. Display the portion of the curve shown. Display the portion of the curve shown. So what is that relationship that's implied by those first 3 points you plotted? Is the task clear? So ask if you need help. Where's Noah? Squirter. How'd it go, Noah?
We use control shift R to
So what was the relationship?
the square
Okay, so he said, he looked at those 3 points and he said, oh, I know the relationship. It's, you just take x and what do you do to it to get y? Take the square root of it. So he said, okay, I want all those points. So he said the square root of x on Mac, that's option V. Square root is option V. On the PC, it's Control Shift R. Control Shift R gives you square root. So he said, I want all the points such that the square root of x equals y. Now, you notice that in my version, I'm only showing a portion of that curve. What portion am I showing? Well, x values starting at 1/2 and ending at 10. So when I display, this is displaying all the points, I can put a comma, and now I can say I only want to display that for certain x values, starting at 1/2, right? And then for Mac, it's option, comma, or option less than gives you less than or equal to, up until 10. For PC, what does anyone know the less than or equal to? PC. Control Shift, comma. Control Shift less than. So Control Shift, comma. Does less than or equal to?
Yeah.
Sweet. So now, what is this saying? It's saying I want all the points that have this relationship, y is equal to square root of x, but I only want that for x from 1/2 to 10. That's not what I wanted. That's really weird. Let's try this. Phew. So for some reason you had to put y equals. You can't do square root of x equals y. So you got to do y equals. I'll get back to you on that. Why that's doing that. But so now y is the square root of x. X from 1/2 to 10. Okay. So now can you plot the movable point that will highlight points on this curve? Can you plot the movable point using n that will plot? Highlight points that are already on this curve. That's the next, plot the movable point. That's the next command line there. Plot the movable point. Where's Sarah Erickson? Sarah. How do I plot a point, first of all? Remember what's that? Yeah, we'll use the n, but I just want to get a point first of all. So remember what I do? Control 2, and then my x value will be n. And how does y relate to x in this case?
X squared, or the square root of x.
Square root of, well, what's my x? N, right? So I want the square root of n, so that whatever n is, I'm going to plot the point that's the square root of n. and then it should work. You should be able to change n, and that will highlight all the different points on that curve y equals square root of x. Okay, so a graph is a set of points. There are many different displays of the same graph. Okay, I can zoom out on the y-axis, and it looks different now, but it's the same set of points, so it's the same graph. Okay, and so we're learning that that's the way GC thinks about it too, right? You put in a relationship of x and y, it's going to show you all those points. It's just curves and lines are a more efficient way of displaying rather than showing you all the points. Okay? But when you see curves and lines, you're looking at an infinite set of points. Okay? Have a good weekend. Recitation, Blackboard or homework on Blackboard.